Section 2.2 is what's here. We've got the square root of a function as our title for this section. And what we're going to do here is we're going to take a look at functions, and then we're going to apply the square root to the entire function and see how the graphs change. So to illustrate this, I want you to consider this function, y equals to 1 excuse me, y equals to 1/2 x minus 1. And now the square root of all that, 1/2 x minus 1. If I ask you to describe the relationship between the equations, well, I think hopefully that's pretty obvious. The second one has a square root. So one function is the square root of the other. Now, let's graph these two out, and we're going to do that by making a table of values. I've already started the table of values by giving you the x values. Yes, I am that nice. And so all you have to do is figure out the y values and graph it out. So I leave that up to you, because I know you don't want to hear my voice. So go ahead and find the y values when you plug in all of the x values. 1/2 times -2, that's -1 minus 1, -2. 1/2 times 0 is 0 minus 1, -1. I don't know why I'm whispering. Just do it. Do the square root as well, so it's the same process, except now I'm going to take the square root of my final answer from the previous one. Square root of -2, no such thing, so no point. Same thing with this one, no point. Square root of 0, oh yeah, that's 0. Square root of 1/2, that's, square root of 1/2. I think that's like 0.707. Yeah, 0.707. It's actually larger. Interesting, hey? Larger. Square root of 1, that's 1. Square root of 4, 2, that's smaller. Okay, let's graph. First of all, y equals to 1/2 x minus 1. 2, -2, 0, -1, 2, 0. 3 is 1/2, 4 is 1, 10 is 4. Y equals to 1/2 x minus 1. And the purple one, -2, no point, -1, no point. So the first point here is at 2 for x, right? 0. Matches up with the original graph. At 3, it's 0.707. It's actually higher. So higher. And then at 4, the y value is 1, so it matches up again. And then at 10, it's 2, so over here. So here's our square root graph. And notice the purple one looks very similar in shape to what we did in the previous section, section 2.1. It definitely looks like a square root function. Part C says compare the y values and how are they related. Well, once again, looks like the y values of the square root one are just the square root of the original y values, or I'll say of the y values of this graph, y equals to 1/2 x minus 1. So what does that mean? Well, the function y equals to the square root of 1/2 minus 1 is, you guessed it, the square root of the function y equals to 1/2 minus 1. That's it. So that's the main idea. We'll summarize this in a sec, But what I'd like us to do now is look at example number 1, and I'd like you to try to, I guess, graph out the original and the square root on the same grid. And then, in addition to that, let's find the domain and range. If you want to make a table of values, you're most certainly welcome to do so. Or if you just want to graph out the line and see what happens there, you're most certainly welcome to do so as well. So, I leave this up to you. I'm going to be quiet. You pause the tape or the video and try it and then come back. Go! F of x, 4 minus 2x. I'm going to use what I learned in grade 10. Y-intercept is 4. Oops, let's use red this time. Red. And then the slope is negative 2. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. That's the function, 4 minus 2x. And then the other function is the square root, right? So y equals to root 4 minus 2x. Maybe I will make a table of values just so that you can see. Original, new. Let's take some negative values. Negative 1, I think. That'd be 6. 0 was 4. 1 was 2. 2 was 0. 3, negative 2. Same x values. Negative 1, so that'd be the square root of 6. That's approximately what, 2 point something. I forgot. Let's do it. Square root of 6. 2.45. Okay, almost 2.5. 0 would be the square root of 4. That's just 2. 1, the square root of 2 is 1.4. 2, the square root of 0 is 0. 3, square root of negative, no point. So negative 1, we're at 2.45. 0, we're at 2. 1, we're at 1.4. And then 2, we're at 0. Probably a graph looking like this. Then domain and range of each. Okay, well, the original one's easy. It's a line, so domain is all real numbers. Range is also all real numbers. Wait a minute, the square root function, there's a problem. It's not all real numbers anymore. It can't be negative y value, so it looks like my domain also gets restricted. X in this case seems to be less than or equal to 2. And the y value, yeah, it has to be bigger or equal to 0. Alright. Did you get that? I hope you did. If you didn't, go back and make the changes. So let's move to page 2. It says in the previous example, were there any invariant points? Once again, what are they? Yeah, they're points that don't change when you do the comparison of the original graph with the root graph. And if so, explain why. And I think in the previous example, there were invariant points. Those are the 2 points that are the same. I think they occurred at 2, 0. And also somewhere else. Can't really tell by the graph, right? Let's go back. But it looks like there's some point right here where they cross at the y value of 1. So I would guesstimate as going to be 1.8 perhaps. I don't know, 1.8 comma 1. Now y, the key thing is to look at the y values, right? The y values, the y values. Well, what's the square root of 0? Yeah, it's the same, 0. Same thing with the square root of 1. That's also just equal to 1. So why do we have these invariant points? Well, it's because the square root of 0 and 1 are just 0 and 1. Therefore, no change. Thus, invariant points. So, I'm going to ask you to go back to those two pictures from before, and I want you to figure out relative locations of the y values. Okay, once again, the y values are what changes. And hopefully we can kind of complete these sentences and that chart underneath, and then we'll use that chart to graph everything else from here on in, and life will be hopefully pretty good and pretty easy. Okay, so let's take a look. It says the domain of the square root function consists only values in the domain of the original function for which what? Well, remember in the previous questions we had those things with no points. Once those y values were negative, we had no point. So therefore, we need to understand that the y values have to be non-negative, or I guess what we're saying here is the y values, which is f of x, has to be greater or equal to 0, right? It cannot be negative. Well, the range, let's talk about the range of the square root function. Of course, that consists of all the square roots of the values in the range of the original function. And of course, this is only true for which the square root of f of x is defined. Because sometimes when we take the square root of a negative, it doesn't work. And the last statement here, of course, is just to summarize. The graph of y equals to root f of x exists only where f of x is greater than 0. I said that in the first line. And then you can predict the location of y equals root f of x relative to the root of f of x using the values of f of x. What do I mean by that? Well, let's look at this chart below, because that ties into the chart. So on the left-hand side of the chart, I'm talking about the values of f of x, the original y values. What I'm going to ask you to do is, based on where the original y values are, can you predict what the relative location of the square root functions will be? Well, our first line here says that the y values are less than 0. They're negative. Well, the square root of a negative number is undefined. So in this case, of course, the graph of the square root is undefined. Or what I said before, no point. When it's equal to 0, well, the square root of 0 is still 0. This is an invariant point, of course. So I'll say invariant point. And notice the graph of f of x really just intersects at the x-axis because it's still the x value is 0. Not the x value, sorry. I would say the f of x value is 0. The graph of root f of x intersects the x-axis since the f of x value, or the y value, equals 0. Between 0 and 1, an interesting thing happens here. If you look back at the previous two examples, it's between 0 and 1 where the actual square root function is actually bigger than the original y equals f of x function. So I want us to make a note of that. The graph of root f of x is above because the y values are larger. The graph of y equals to f of x. When it's equal to 1, once again, an invariant point. Notice the graph then intersects at 1. And when it's greater than 1, you see that the square root of those values are always less. So graph of root f of x is now less, so it's below the graph of y equals f of x. Okay? If you know these things and can keep them in your mind, you can graph out any square root function of any original function. Okay? And I'm going to ask you to try that right now with example number 2. Okay? It says identify and compare domain and ranges of the following pairs of functions. I'm going to ask you to graph them out too. Try that by finding the x and y intercepts along with the max and min value. Oh, parabola stuff. Remember that stuff? Parabolas? Oh. Grade 11 coming back to haunt you. Well, domain of a parabola, I hope you remember, is just all real numbers. In this case, the range, well, that ties in with the max and min value. You've got the vertex. Remember that vertex stuff? Look back at your grade 11 notes if you're not too sure. 0, 8 in this case. Opens down because of the negative, so y must be less than or equal to 8. We want to find some x-intercepts and y-intercepts. Let's do the y's first. So the y-intercept, that should be easier. Negative 2 times 0 squared plus 8. That's just 8. And then the x-intercept. This one's a little bit trickier. You let y equals 0. Gotta solve for x. Do some nice algebra. Get 4 equals to x squared. Don't forget to take the square root and put the plus minus. There we go. Let's graph these out. We've got y equals to 8. Got the x-intercepts. Here's my nice thin parabola. Now, what about the square root function? Okay, let's think about this. Let's use our information from above, okay? Where the graph or the f of x values are less than 0. That would be down here, right? Gone. No square root function. Okay. When it's equal to 0, they intersect. So let's use purple as my square root function. So I guess my x-intercepts are still the same. Plus or minus 2. Plus or minus 2. Between the y value of 0 and 1. So now I'm talking about this region right here. Okay. Here's where the y value is between 0 and 1. Okay. It says that the root function is above. So, above. So, if I were to use my purple pen again, well, it's kind of hard to see here, I guess, but it'd be above, so higher. So higher, higher, okay? At 1, looking at the chart, oh yeah, that would be intersection, so intersect, intersect. And then when it's greater than 1, that would be this whole region here. This is all greater than 1. We are saying that the square root values are below. So the square root of 8, I guess that's my y-intercept. Not just 8, but the square root of 8, that's about 2.8. So right about there. So I think this is what it looks like. Like that. That's the purple piece. That would be the square root of negative 2x squared plus 8. Notice your domain then, in this case, it's not all real numbers, but it's between the values of negative 2 and 2, your x-intercepts, and your range seems to be bigger than or equal to 0, and also in this case less than or equal to root 8. Okay, one more on page 3. I'll let you try that out on your own. It's another parabola, so go ahead and try it. Come back and check your work with what I'm going to write down here. Okay? Don't cheat. Do it and come back. Next equals to 2. 2 squared is 4. Half of 4 is 2. Plus 1 is 3. Three, okay, 4, 16, half, 8, 1, 9. Much wider parabola. Square root. Okay, so once again, no negatives, don't worry about that. Using that chart equals 0, no x-intercepts, forget about that. Between 1 and 0, no values there either. So I guess everything just is a little bit less. So square root of 3, how about 1.73? Square root of 9 is 3, so I think the function looks like this. Oops. Same thing here. To the root. For something like this, there's your square root function. Domain. This case is still all real numbers. Range looks like it's greater or equal to 1. Y-intercept is still 1 because that's my invariant point. No x-intercepts. Alright, great. Last but not least, what if I actually gave you the graph and I asked you to now sketch it out? Once again, use that chart on page 2. So I don't really want to do this with you because I think it's pretty self-explanatory. So I'm going to ask you to try it. Remember, use that chart. Look at the y values that are less than 0. Then look at the zeros. Then look at between 0 and 1. And then look at between 1 and I guess infinity. Okay? I'm going to let you try this because I think it's pretty straightforward. Come back, check your work, and then we're good, hopefully. I think you should be good. Okay? Go for it. Okay, A. We're going to look at less than 0. That's this part here. Less than 0. Remember, square root function does not exist. Too bad. Then we have equal to 0. It's an invariant point. Okay, let me use red. Invariant point right there. Boom. Okay? Values between 0 and 1 are next in my chart. That's this stuff here. And we know that the square root function is always above. Okay, so let's go above, randomly above. So we, and then we know at y equals to 1, invariant point. Okay. And then now bigger than 1, what happens there? That's all this stuff over here now. Oops, wrong color. Here we go. All this stuff over here. Then, of course, these values are going to be below. So let's go below. Let's take square root of 4. We know that's 2 below. So we see something like this as your graph. Okay. Here's y equals to root f of x. Notice nothing to the left of approximately 2.5 in this case. Okay, here once again, we're going to separate them. Less than 0, between 0 and 1, more than 1. Okay. Okay, negative parts, nothing's there. Zeros, invariant point. Y values between 0 and 1 in the green band there. You know that the square root function is higher. So higher, 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 higher. At 1, when the y value is 1, we've got other invariant points. We probably have this so far, and this so far. And then, of course, when the y values are bigger than 1 in the blue section, the square root is below it. So I'll just use 4 as a quick example. That's 2, so probably something like this. Probably something like this. Oops, that's not good. 4 became 2. And probably symmetrical too, so I didn't draw very well. But you get the idea. Okay, double check my invariant points. Guess from the first one in part A, yeah, it looks like 2.5, comma 0. Remember the y value is 0. And also 3, comma 1. Over here, I don't know, let's say negative 2, comma 0. 2, comma 0. And some point a little bit to the right of that. I'll say approximately, what would that be? I don't know, 2.2, comma 1. That's just a guess, okay? Guess. If you had a graph and calculator, you can figure it out. But in this case, I'm just guessing. Alright, we're done.